In this question here, we are given a pattern. This is the pattern. And we are told that it is due to 8 slits. Okay, notice here we have a very bright principal maximum, and then we have secondary maxima in between, and we can count them. 1, 2, 3, 4, 5, 6. 6 between two principal maxima. And that corresponds to n, which is 8 minus 2. So I have 8 slits, so I have principal maxima, and between the principal maxima I have 6 secondary maxima. 6 secondary maxima. The question is, how would the pattern be different if we double the number of slits, maintaining everything else the same? And we are told that the distance separating the slits from the screen is 1 meter, the wavelength of light, this green light, 500 nanometers, and that the distance separating the outermost fringes is 16.8 meters. That's from here to here is 16.8 meters. Now, the good thing is, for multiple slits, the number of slits does not affect the position of principal maxima. That's whether there are 2 slits, 3 slits, 4 slits, 5 slits, 100 slits. As long as everything else is the same, the position of the principal maxima, these bright fringes, is going to stay the same. What's going to change is the number of secondary maxima. The width of that fringe is going to, the more slits we have, the thinner it's going to get, and how bright it is relative to the secondary maxima. Now, the expression that we use for 2 slits and more is going to be the same as the expression that we used in a previous question. This one here. D sine of theta is equal to n times lambda. That's the expression that we use for the principal maxima due to n slits, where n is larger than 1. This is applicable for 2 slits, 3 slits, 4 slits, 5 slits, whatever. It gives us the position of the principal maxima, the angular position, of course, theta sub n. Notice that this expression depends on the slit separation d and depends on the wavelength of the light. That's all. These are the only 2 factors. Now, if we are under the small angle approximation, if the angles used, if the separation slit is quite small and the distance from slits to screen is quite large, so that our angles are small, we can use this equation as well for any number of slits. Lambda sub n is equal to n lambda L over d. But remember, that's applicable only under the small angle approximation. And again, remember, this equation indicates that the only factors that are going to determine the position of these principal maxima are going to be the wavelength, the separation of the slits, and how far are we from the slits, how far is the screen from the slits. Look here at several patterns. The first pattern here, you see the principal maximum is quite extended, is quite wide, and we see 3 secondary maxima. So this one should correspond to 5 slits, because the number of secondary maxima, remember, is the number of slits minus 2. So here 5 minus 2 is 3, that's what we see here. This is the one that was provided to us. 1, 2, 3, 4, 5, 6. This is the 8 slits. Now, this one here is for 10 slits, not really the double that we are asked for in the question, but it's for 10 slits. We see here 1, 2, 3, 4, 5, 6, 7, 8. Notice how as we increase the number of slits, that principal maximum gets thinner and thinner. And it's brighter relative to the secondary maximum. Now, the brightness, actually the intensity, if the intensity of the light coming from one slit is I, the intensity of the principal maximum is going to be n squared times I, where n is the number of slits. Okay, now in the second part of the question they are asking us to find the slit separation. To find the slit separation, they are asking us for D. So very much what we can do, we can measure the separation between two fringes. For example, here, remember they told us 16.8 is the distance separating this fringe here from this fringe here. That's so we have 1, 2, 3, 4, 5, 6, 7, 8. So if we divide that by 8, we get delta y for this case, which is 2.1. Again, we are abiding by the small angle approximation in this question. In future question, in a later question, we will not abide by it, so you'll see how you can work it out. Now here, we know our delta y. Delta y should be then equal to lambda L over D. We just solve for D. That's the question.